Hey, ladies and gentlemen, we are going to talk about properties of parallelograms today. Parallelograms are kind of be that umbrella term, and we're going to see some quadrilaterals that satisfy being a parallelogram over the next few days. And then we're going to end up with also seeing some quadrilaterals that don't fall into the parallelogram category. But today we're going to learn all about parallelograms and properties for them. So first up, we're going to start off with a parallelogram has two sets of parallel sides. Two sets of parallel sides. Okay, so if you see something that has two sets of parallel sides, it's a parallelogram. Parallelograms have some other properties. Here. It says if a quadrilateral is a parallelogram, so I'm telling you that this is a parallelogram, then the opposite sides or opposite legs are congruent. So if you know it's a parallelogram, you can automatically say, hey, the legs that are opposite are congruent. The converse, which is our second sentence, is also true. So now I'm going to tell you, hey, you have a quadrilateral. Both pairs of opposite sides are congruent. Then this is a parallelogram. So I know that sounded the same, but it's really a little bit different. So the first one says, I'm telling you it's a parallelogram. You can assume the opposite legs are congruent. The second one says, if I have a quadrilateral and the opposite legs are both sets are congruent, then I can determine that it's a parallelogram. Kind of seems a little bit the same. It is. All right, we can see the same thing here in angles. If it's a parallelogram, opposite angles are congruent. And I can say the converse that if I have a quadrilateral and I notice that the opposite angles are congruent and both sets of them are, then I can say, yes, it's a parallelogram. So we'd say like angle J is congruent to angle L and angle M is congruent to angle K. And we also have another one that deals with angles, and we talk about consecutive angles. And consecutive angles are supplementary, which means they add to 180. And we know this to be true. Think back to Unit 2, where we talked about parallel lines being cut by a transversal. If we look here, we have parallel lines, and they're cut by a transversal. So angle J plus angle M equals 180. Those are consecutive interior angles. And you can see the same thing if we look at these are my parallel lines, and this is my transversal. Now we can say okay, angle J and angle K, those are also consecutive interior. So those also add to 180. And you can do the same with angle K plus angle L is 180. And angle L plus angle M equals 180. So 4 sets of supplementary angles. All right, we're really cranking through this, guys. So find the values of x and y so that the figure is a parallelogram. So we would need to say my opposite sides have to be congruent. Now, if you look, we have this one here. It has x and y. So we're going to have to solve for the x one first. So 6x plus 3 equals 15. Subtract over your 2. So 6x equals 12. And we end up with x equals 2. Right? I can plug that 2 now into my 4x. So that gives me 8. So now I'm going to say 8, minus 2y is equal to 2. We're going to subtract 8 to both sides. So negative 2y equals 2 minus 8 gives me a negative 6. So y equals 3. All right. In this next one, we see we're talking about angles. So our two angle properties where opposite angles are congruent and consecutive angles are supplementary. So I notice that my angle A and angle C both have y's. So I'm going to set those equal to each other. Y plus 10 equals 2y minus 40. I actually, in this one, wouldn't find x first because I don't have enough information yet to be able to determine x. So go ahead and minus y over and add 40 over, and I get y equals 50. I'm going to use this 50 and I'm going to plug it back into, I can plug it into angle A or angle C, but that's going to help me with B because those two angles are supplementary to B. So I'm going to plug it into A, just because that one's a little simpler. So angle A is 60 degrees. So angle A and angle B are supplementary. So 60 plus 4x equals 180. You'd want to subtract over your 60. So 4x equals 120. So x equals 30. All right, so let's go ahead and talk about another property. This is what, property 4 or 5, something like that. All right, if a quadrilateral is a parallelogram, then the diagonals bisect each other. So think about, what does bisect mean? Bisect means it's going to cut it in half. So you need to write that down, that cuts in half. When we say cut in half, that means it's split into two equal portions. So AP is half of my diagonal AC. So I would say AP is congruent to CP. I can say the same about the diagonal BD. BP is congruent to DP. All right. Then let's go ahead and look. The second sentence is just the converse. It's just saying, hey, if you see two sets of diagonals that are bisecting, then automatically this is going to be a parallelogram. All right. So here we're looking at these two sets of diagonals. We have 4x minus 2 and negative 4x minus 2 and negative 3x plus 4. So I'm going to set those equal to each other. And we're going to solve for x. So I'm going to go ahead and add 4 over. So negative 2 equals x plus 4. And I'm going to minus 4 over. So I get negative 6 equals x. Ooh, a lot of us feel really uncomfortable when we have a negative answer. But let's just plug it back in and see if that works. So we're going to plug it in here and here. So negative 4 times negative 6 turns into a positive 24. Minus 2 gives me 22. So even though my x is negative, when I plug it back in, it actually turns positive because it's being multiplied by negative. Let's check the other side. Negative 3 times negative 6 gives me a positive 18. Plus 4 gives me a 22. So it actually does work, even though it's negative, and we feel uncomfortable about that. All right, so 3y minus 5 equals 2y plus 8. 3y minus 5 equals 2y plus 8. Go ahead and subtract over the 2y, add over my 5, and y equals 13. All right, here we're looking for x, y, and z. It does not matter in this one which one we find first because none of them rely on each other. So let's just go ahead and start with x. So 5x is representing this whole side. So because this is a parallelogram, it's going to be equal to that side. So 5x equals 27. Go ahead and divide 27 by 5. All right, we end up with 5.4. Again, it's okay. You can't have decimals. Life is full of not whole numbers. All right, we're going to go ahead and look at finding y. 2y minus 5 represents that. Y plus 4 represents that. So those two should be congruent because diagonals are bisected. So I'm going to minus y. I'm going to add 5. And y equals 9. All right, so I'm going to look at 3z here. And I'm going to do a little drawing. So, oh, actually, my blue, nope, I don't want my blue ones. All right, so these two lines are parallel if this is a parallelogram, and this is a transverse that cuts through. Excuse me, I'm not being very accurate with that. So this angle here is going to be congruent to this angle because they're alternate interior angles. So 3z is going to be equal to 33, not equal to this 95. Don't make that mistake. It's a super common one that people do, is that they'll make the mistake of say equaling to the one on the same side. All right, so z equals 33, z equals 11. All right, let's move to the next one. This is our last theorem we're going to talk about. It says, if one pair of opposite sides of the quadrilateral is both parallel and congruent. So it's one pair of the sides are parallel and congruent. Then we can say, yes, this is a parallelogram. All right, so let's go ahead and look here. We have 4 problems here, and they are, all of these are possible parallelograms. We need to decide, is there enough information to say, yes, it is, or no, it's not. So if we look at the first one, I see I have 2 sets of opposite sides that are congruent, 5 and 5, 12 and 12. So yes, this is enough information to say that this is a parallelogram. All right, let's look at problem 6. I see I have angles and sides here. I have 85 is equal to 85. Yeah, that's true. But the thing is, I don't know what's happening with those other angles. So I don't have enough information with that. And I only have 1 set of congruent sides. I don't know if my other sides are congruent. So we're going to say no, only 1 set of congruent sides and 1 set of congruent angles. All right, let's look at 7. I see those little red arrows, and just a reminder, those little red arrows mean that those sides are parallel. So that set of sides is both parallel and congruent. Does that have enough information to say this is a parallelogram? Well, if you're not sure, look directly above in your notes at this theorem here. This says if 1 set of sides is parallel and congruent. Well, look, we have 1 set of sides that's parallel and congruent. So then, yes, this is enough. All right, let's look at 8. 8 only tells us that 1 set of sides is congruent. That's a no, not enough information. Only 1 set of congruent sides. All right, last problem we have here. This one is telling us to graph it. I'm not going to make you graph it, but it says determine whether the quadrilateral is a parallelogram. Justify your answer by using the slope formula. Why would we need to use the slope formula? Well, think about the very first theorem that we wrote down, or definition that we wrote down for a property of a parallelogram. And if you don't remember it, flip your page, look back at it. We wrote down a parallelogram has 2 sets of parallel sides. And slope tells us if my lines are parallel. So if you find the slope for all 4 lines, you will be able to know if they are parallel. So I want you to go to the very bottom of your notes here, and it says, the quadrilateral is a parallelogram when, and in that place I want you to write, you have 2 sets of parallel sides. You have 2 sets of parallel sides. And if you need a reminder, parallel slopes are when they are the exact same slope. So go ahead and pause the video here, and I want you to find the slope of all of these lines. Reminder, slope formula is right here on your slide if you don't remember. So come back here in just a couple minutes. All right, hopefully you guys did that. And slope of QR, we get -1/2. Slope of ST, we get -1/2. Ooh, 1 set of parallel sides. Slope of RS is 4. Slope of TQ is 4. So another set of parallels. So is this a parallelogram? Yes. Opposite sides have the same slope, therefore they are parallel. So this is a parallelogram. All right, there you have it today, ladies and gentlemen. Thanks for joining us. We'll see you later.